So every machine learning model learns or trains by solving one problem, which is minimizing loss or minimizing error. Now, when you're training a real model, it could be a linear model, a neural network, or a language model, there is no formula to straight away jump to the best answer or the best minimum value, right? And that is where gradient descent will help us to find that or iterate our way to that particular minimum. Okay, so the way it works is it updates parameter by moving them in the direction that reduces error the fastest. That's basically it. Okay, just to show an example, let's take this simple one-dimensional function here, which is f of x is equal to x minus 2 to the whole power square, right? Now, the minimum of this function is when x is equal to 2, because that's where f of x becomes 0, right? This is a pretty straightforward example where you can just plug in 2 and find the answer. But for when you're training a neural network, you need a function or a process which will reiterate, automatically iterate its way to the minimum value. And that's why we use gradient descent. So for just to show how gradient descent works, so I'm gonna use gradient descent to find the minimum of this function f of x is equal to x minus 2 to the power to the whole power square. And I want to start x is equal to 5, let's say. And I want the step size, each iteration size to be, or learning rate to be 0.2. And I want 10 steps in total. Okay, that's pretty much it. Then I'm creating a function which is for I in range steps, which is 10. First, we need to find the gradient, which is nothing but the slope at the particular point x, which is 5 to start with. And if you make this calculation here, which is 2 into, you just plug in 5 there, that'll be 6. 6 is the gradient, which is an uphill. Now, our minimum is at 0, so we need to bring it down. So what does gradient descent does? It slowly brings it down to 0. That's exactly what it does. Now we are finding the distance to move in the negative direction to come closer to 0. Okay, that's where we are plugging in the learning rate, which is 0.2 into gradient descent, which is 0.2 into 6, that'll be 1.2. Now, then we find the latest, the newest x, right? So that is x is equal to x, which is 5, minus the distance, which is 1.2, and that will give us 3.8. Now, plugging it all together in a visualization, if I run this up, this is the function you will, this is the chart you will get, which is you start at 5, that is the x value. Then the loss is minimum, or it ends at 2. That is simple as that. Okay, so now this, since like I said, this is a very simple function, but when you're training a millions of parameter models, it'll come in very handy. And this is one of the effective ways, like most of the neural networks are trained on, to reach the minimum error or minimum loss possible.